Assalamu alaikum. Hi everyone, welcome back. So today we're going to talk about k-mean clustering. So for those who are not familiar with this series, where recommendation system in Python, so don't be confused. Is just we have data set and we just going to apply k-mean clustering. The only for those who are already familiar with this series, the only difference is they know about the data, how we create the data set, and we have implement the data set we have created is grouping item using clustering. So where it was online blogs, we try to cluster them, and for this purpose we extract the online blogs and create the data set using TF frequency of each word. And so let's discuss. Last time we have discussed k-mean clustering. On some point, someone would not go to apply k-mean clustering in the scenario where we face like if you see here. There are these are, for example, consider is rows, row 1 2 3 4 5, and this is the node. Consider it as a node. So having this is having some feature, and on the basis of feature there are distances calculated between them. So distance is calculated between them, and on the basis of this distance they are merged together and recalculate this distance and again merge, and same is here. So the problem here is no, there is no problem here for. So here if you see this is repetitive process of recalculation, which is extremely computationally intensive. So for the large databases, if you see here, if for the large for small database, it's okay, it will work better. But and it also works for large databases, but the algorithm will run slowly on very large data set. The third point here is there will be no clear boundary after the cluster of the data. Okay, so we will go for k-mean clustering. Let's see how it can clearly overcome these three problems. Okay. So so what kind of problem we can solve using k-mean clustering? So grouping V of same nature on the basis of gender or rating score. If you look at the Netflix, they are grouping the oh my god, mistake. They are showing group of movies by similar movies together, are according to your according to your flavor or whatever you can say. But the grouping criteria could be different, but they try to apply the clustering in the in their website, on their web platform, whatever you can say. So another here is for example, if you download the books and it automatically plays in the shelf, a bookshelf with the similar books. This is a good idea, and you can see in iOS devices. So classify the hundred of thousands of documents based on their topics and content, whatever could be the parameter. There are different parameter people could be used. So these are taken just for example. And you just wish to group together a different images for some reason. It is also possible, and there are different scenario where there are different projects where images are similar images are grouped together. Like for example, if you give bird to, or if you give image to the Google image search, so it will search for you the similar images. Okay. There is important point here that is to be discussed, and where you can use it okay, clustering. For example, let's think that you have the same data already. For example, you have the you have data set and already labeled, but you just want to challenge the labeling criteria. For example, if they are labeled already and you just want to clarify for yourself that using this model, I just want to check out either these labels are given correct or not, or maybe you just want to you just want to clarify for yourself either using this model how much this model is going to check the accuracy of labeling as given to the original data set. Of course, I am talking about training data set. All right. So here is another important point, that is news clustering. It can be used for news clustering. Okay. Image segmentation. Last time I have a small project and I use image segmentation for the purpose to extract the license plate number. Okay, so license plate number from cars in the pictures. So let's discuss the important steps of k-mean clustering. So if you look at here, it just randomly started from here. So the question is why it doesn't start from here or out of the range. So the logic is that before you generating the random number, you have to decide the criteria. You have to decide the you have to decide the range. In what range do you want to generate the random number? So all the numbers, all the feature will be generated randomly here from in this range. So okay. So as you can see here, that pick the key random points as a cluster central car centroids. Okay. So and assigned nearest cluster by its distance to each centroid. Okay, distance is given, and it means that after generating a random points to the centroid, an arrays cluster, points is given to feature number is given to feature point is given to each by calculating the distance to each centroid. Okay, then it is going to be more closely to the center place. I'm sorry, to the center place by taking the average of centroid point assigned points. Okay, and repeat this process until we have stop criteria fulfill the stop criteria. So there are different stop criteria, and one is using a distance. Okay, either the distance last time the distance, or you can say error. The error last time found is similar to the error generated now, or you can just compare the centroid. Both are same. Okay, previous centroids, if previous centroids equal to new centroid or current centroid, then break. Okay, or error equal to new error, then break. Same, both are similar. Okay, so let's jump into the code. All right, this is the code portion. Let's discuss what is going on here. So before we jump and apply the coding, there are data sets that need to be discussed. Is very important here. Let's remove this one. I don't like this teaching. Okay, so we have the same data set. We have three type of data set, but we will play with these two data set. Okay, so where we have to same data set in different format. If you look at here, this is the data set. Okay, so it is having block names and it is the column names up to the here. So approximately it is 706 columns here, and in a data set that is which is in text format having a block name in every column, in every row. Okay, if you hear this up to how many rows we have, 99 rows. Come on, come here. It is lazy. Sorry, it is lazy. Okay, it is 100 but it will be 99 rows. So how I change the same data set? By removing these, okay, and these and all these names in blocks name and convert into the CSV format. Okay, if you see here, this is the CSV format of same data set having no block name, okay, no tape space and full data set. So we will play with both of data set. I mean, if I will apply the same algorithm for using text data, and again we will see you can change, how you can apply the CSV format data in the same algorithm without changing any logic inside the algorithm. Okay, so let's just discuss the points here. Okay, this is a code portion. You have to just import all these libraries, and now we have to think about how can we extract the data from text file. Very easy peasy. I just grab this code and let's understand this code, how it's working. And the first thing that need to be discussed here is the line, and it is going to extract all the data from the file without removing anything. It is just the way to read the text file. Okay, so what is going on here? This is going to extract the column names but just targeting the index 0, which means just only row 1. Okay, this row index. Okay, and next thing it is going to do is just remove leaving this blog name, okay, here, and extract all of the remaining data and append into the list here. Okay, if you see here, let's just remove this so that we can make it easy. All right, this is print call names. All right, so this is having blog names, and if I just put there blog names, no, here blog names, it is not having to be again here. So this is how we can just avoid the column or any data if you want. And this is going to be the next thing that is going to be extract a row name and data name. So how it is going to work in this case is, you see that P is just avoiding the block name and grab all of the rest of the data. So you can see here that it is having the data set here. So before we jump into the code, let's discuss. I haven't discussed these things. So I have the same data set that is txt format, all right, and the same data in the CSV format. The only difference the things that I have just extract these things, remove the tape space and these names and these, and replacing it with the comma to become this data set and CSV format. Okay, just simple. So what we was discussing, to remove the data, okay, this is just helping to avoid the block name which we have here, block name. All right, so this is going to be iterate, and all of the data is going to be appended into the data one by one after it is iterated in floatly extract into this list which is having boundary here. And again I will say this is how it is going to extract all the row name, mean block name, if you just want to just for the sake of simple understanding, print. Oh my god, you can see here this is the block names. So all the block names is going to be extract here. So this process will continue until its death of the loop, so that we can extract all the information. So if you look at here, print block, no need to be print block name, you see here, and data, you see here. Alright, so what is the length of block name? Block names 99. So what would be the length of 99? So this is for the extracting the code portion, extracting the information from the data. Now let's jump into the algorithm. Okay. All right. So this is the algorithm that we going to explore. So first of all, I have already told you, you have to decide the range in the data. I mean, for example, if you look at here, it is, for example, having a range, and inside the range you have to decide you have to randomly generate the number. So okay, so this is going to be have the range for it. So how it is going to decide the range? So the way it decide the range is very simple. So it is having so how many time it is finding the range. So this loop will be iterate for the 70910, how many column for all the columns time. So in every column it is going to extract all the data from column. Here you can see here, and also extracting data from the same column again. So the difference is it is going to find a minimum and it is going to find a maximum in the same column. So how this logic is going to work? Okay, so for example, it is going to having 0 index. Okay, 0. So the 0 column is target here, and it is going to iterate 99 times. Let's see here how it is going to 99 times. For example, I have to open this data set in Excel format so that you can easily understand it. Okay, so if you look at here, this is all the columns names. Okay, so for example, it is having you can see here it is having index 0. Okay, row length of index 0. So on index 0 it have to iterate for all the length of rows. You can mention here length rows. Okay, it will iterate 99 times. So in 99 times, so how it is going to work? Okay, in 99 times, no, you cannot use length here, because every time it extract the new row and new row and new row, and you have to target the same index. Like for example, row 0, you have to, for example, you have index 2. Okay, so I is equal to, you have to target this one. I is equal to 1, it is 0 and 1. In row 2 it is going to target these 3, 4, 5, 6, 7, and same is here. If it is going to have a index I is equal to 5, so every row iteration will extract the new row, and iteratingly it is going to downward, and so on until it is going to have the full data of the same column. So after grabbing the same to full data from this column G, or we can say service, what is going it or how it is going to do. So after extracting all the data, it is going to decide the minimum number in the same row, and again same iteration, and here, and this is how it is going to extract the data. So let's see how it is working, how it works. All right, just okay. I am just doing break this code so that you can easily take help from it. Okay, you see that in the row 1, in the column 1, the minimum value is this and maximum value is this. Okay, and so on. You can go there. So how many rows, how many ranges, what will be the length of ranges? How many rows we have? 706 rows columns we have. 706 columns we have. So it is going to extract summary again. It is going to extract the data from column to column and finding the minimum and maximum value from column. Okay, so this is going to decide the range. So once it decides the range, how it is going to extract to create the centroid? Well, so this is random. So what is this? So this means that random. I will make it easy for you. So how it is going to extract, thus create the centroid. Okay. So it is going to no. So it is going to iterate for the k time. I mean this is going to create data into the centroid. How many centroid we have? Length is equal to 3. So what is going here? What is going on here? It is going to be repeat. This process is going to this equation is going to repeat for 3 times. So what is this? So this is random. It is going to generate the random value between the 0 and 1. So what is this? It is going to subtract the minimum value from maximum value, and again after multiplication with this, it is going to add again the minimum value to this. So this is the equation to generate the random number into the cluster. Okay, so again, so let's see here how it is getting. So this is the cluster it is created. So what is the length of our cluster? Okay, let's see what is the length clusters. 3. So we have 3 centroids here. Okay, let's make it more easy. So how it is going to work? So what is now? So we have created the centroid. Now it is going to move to the center point and find the distances. Either we have the error rate same, or Android is same to, so that we can stop the cluster here, algorithm here. So you can see here, let's make it more easy. Okay, so you can see here last matches. So if you see here, this is the last matches which is going to be used in the stop criteria in our algorithm. Okay, so if you see here, the last matches best. Okay, this is going to be Okay, so this is, if you see here, this is the last best match equal to last match. So it is going to iterate infinitely, having true value in a while, until we match this condition. It match this condition. So the best matches is going to have to save the indexes number, the element indexes number. Okay, so indexes number will also if this condition match, which mean that the indexing number of the best match of current best match is equal to last match. So what is last match? Last match which is assigned, which have assigned, which assigned, or which we can say a best match value is given to last match if this condition is not matched fully. Okay, so in the first time it will not terminate, because it is not going to match, because it is already having last match is having full null value. Okay, none. So none is not going to be matched. And next it is going to be so best match is going to be assigned into the last match, and in the next iteration when it comes, last match it will take check again. If it is matched, then it will having to break last matches and best matches when is going to the terminate condition. So this means that it have returned the same indexes, so there is no distance between the centroid. So centroid is in the perfect place, in the perfect center. All right, so let's see what is here for us now. Okay, all right, so so what is going here? So while initially it is going to initialize the best matches list of value k, having all the index is null. Okay, if you see here, every time it is going to initialize the best match is equal to null. Okay, right, so it is having null. So again it is in the next step, finding which centroid is the closest to the for each row. So in this time in here we are going to calculate the distance between the centroid and the current row. So for example, it is going to terminate, it is going to iterate through all the rows. We have 99 rows and j is in extracting the index. So in the first index, it is going to assign the rows is assigned into the row by targeting index. So and best match is going to have 0, which is initialized, so 0. So all thing is going to happen here. So finding the distance between the current cluster and current row. Okay, so distance, if you see that it is going to terminate, it is going to iterate for 3 times. So how it is going to work, this area, let's see here. For example, we have a centroid, okay, and index is 8, for example, and this index is j is equal to 8. So this is going to find the distance. So first it is going to find the distance between the centroid 0, and again going to find this distance centroid 1, and again to find the distance in the centroid 2. So this is how for all 3 centroids it is going to distance for each rows, and this distance. And once this distance is going to find, and again it is going to find the compare if distance of the current centroid is less than the distance between the best match, which is index here 0, and either if this best match distance is less than this, then it is going to be replaced. Okay, and again it is going to the minimum distance indexes are going to be found here. Okay, for example, For example, on the second iteration, so on the second iteration it is going d is less than this best match, so this d is more closer, means that the distance which is found for centroid 2 is more closer than the distance between the cluster and current row, okay, between the centroid of best match index and current row, which is for now is 0. Okay, and this is on index 2, so this distance is less than this, so the best match index is going to replace by this. Okay, so now in this condition best match is going to have a 0. Okay, no, sorry, 2. So this is how for each row it is going to save the index it is going to decide in the 3 centroid which one is the closer to the particular row. For example, it is have to decide either centroid 1 or 2 or 3, which one is more closer. For example, 2 is going to be safe, and for this it is going to be 3 is going to be safe, and it is going to be 0, 2 is going to be 0. This is how it is going to save all the cluster. So in this coming down, so it is going to best match which is already updated here and append here for each row. Okay, so let's see this, what is going in this best matches. Okay, you see here, so this is going to update gradually. Okay, first it is having 0, in next station is 1 2 3 4 5 6 7, so it is having row by row names. Okay, and again it is going to update. What I mean to say is, if you see here that it is having three empty indexes, okay, so on every indexes, so it is going to append best match. So which index? Second. So on the second index, on the second centroid, okay, it is going to append the J. Okay, and again in the second centroid, and the first which one is going to be best, first, second, or third. So this is the best match will either 1 2 or 3. Okay, so in the best match 1 2 or 3, all these indexes is going to be append in the case if the D is more closer. Okay, so this is how it is pointing to find the closest distance. So if you see here, let's see if output. So this is the 3 condition. Okay, all of them is empty, so the 0 index is going to be append in these best matches. So in which centroid it is going to be append. So it is decided that the more closer one is this, so it is going to be the more closer one is second centroid that we have already created, so it is going to be append, and so on. Okay, and so on. And again here it is calculated, and it result we have found here that second one is more closer than rest of these, say first and third. So this result is going to be happen again and again until we have 99. We have at rate 99 of rows. Okay, so this is how it is going to be append in this best matches. I think it is more clear. If it is not clear, please mention in the comment whatever is your question, but it must be about algorithm. so what's going on here? So this is the closing criteria as I have discussed. If the best match index, no, so in here it is going to last matches, best matches is going to be the assign in here, so that last time it is coming back. So after in the second iteration or in any iteration, it is going to match the previous, is going to previous, not into the best match, previous centroid into the best, last match is into the best match. So this is the criteria where we can stop the algorithm. Okay, now we have two things. We have to find the average, and also we have to update the cluster. Okay, now if you see here, now moving toward the centroid to moving the centroid to the average of the number of the cluster, iterating to the k number of android. Okay, so it is going to be iterated for the 3 time. All right, this is going to be simple in the second line. So it is going to initialize the average of length 706. Okay, and all of them is going to initialize with 0.0. All right, if you see here, avgs 0.0. okay, not difficult. So what is this? So it is going to decide the criteria if best matches index is, if best match is going to greater than of index is greater of length than, because sometime you might have, you see that the best matches index is of length 0, so it must be fulfill this criteria that the best match length must be greater than then. So after fulfill this condition, you have to find this. Otherwise, if it is not having this much length, there is no need to come here and calculate the average and decide and update the centroid for it. All right. So and after this we are going to retrieve the indexes. Okay, so how it is going to work? So this is best matches indexes is, so best matches indexes, whatever it indexes it will retrieve. Okay, taking the length equal to the current cluster, it is good. So row index, row id, so row id it have an index which row it is more closer in this best matches. Okay, so for example it is centroid 1, and a centroid 1 it is having row id, for example it is 15, and that row id, so that row's id is taken to be as a length here, so that we are going to after, let's clear it more. For example, if you have 15 row, so this row id is 15 row. Okay, see here you have row id 15, so it is going to jump here. Okay, and now after jumping here, you have to take every one of these, okay, on to the last one. So how it is going to do? So it is going to do like this is the length, taken the length, yes. Okay, so this makes sure that we have to iterate from all of this row. Okay, it is clear for us now what is going on. Index, okay, so averages, you have seen that the length of averages, okay, it is of same length. Okay, there is no confusion, it is clear. So on index mean that on index 0, okay, on index 0 it is going to target the row id that is 15 and index. So it is going to iterate all the data from this row and grab it and put it in the here averages. So this is how it is going to put the data into the average. You can say that is going to be later on a centroid. Okay, now how it calculate the distance, how it calculate the average. So this is going to be so how it is going to be the average. So all the data extracted from here is going to divide by the length of all this length of full row, which is finding the average. Okay, total number of current index divide by total numbers. Okay, this is how we take average normally. So it is going to have average. So after it iterate the average and calculate the averages and assign the value in the new way, this is going to update the cluster. So how it is going to update it? If you see here, it is going for iterate 3 times for index 0 for, or we can say that for centroid 1 it is going to be update, centroid 2 it is going to be update, and centroid in the case if it fulfill this condition. All right, in this way, so this will happen, this will continuously iterate until we match this, it fulfill this best match criteria. Okay, so let's see how many centroids we have. So in the first centroid it is having these indices, and the second centroid it is having these indices, and the third centroid this is empty. Okay, so how it is going for, all right, temp index in best matches, that is going to be 0. Print blog name index. Alright, just copy paste it, blog name. Though the distance is not need to discuss. So one thing that is more important I haven't discussed here, this is we find the distance between centroid and current row by using occlusion distance, which is very simple equation. By first point in the space minus second point in the space by taking square and root, sum of root. And so let's make it simple. I will just extract the formula from. Alright, this is equal to this. This is for example 2 point into this space, and you want to distance or similarly for similar purpose, or you want to distance or how much distance between it have in space. So this is how occluded distance is used: x2 minus x1 taking square plus y1 by 2 minus y1 and taking square and under root. So it is going to be simple. So every point in the both of centroid is going to be calculate in this way. Okay. Alright, I hope it is now clear for you. Alright, so let's just block names. It is very simple. Okay, how much blocks names we have? Alright. Okay, so this is the block names. These blogs are similar: Google operating system, official Google blogs, quick online tips, Google Blogscope, read, and wide web. You can see there are similar things in here. You can Google, it is all thinking about Google technology like things. And what about this one? Oh my god, this is going to be confused. Alright, this is going to be a similar blog, cluster. And now this one is so cute, it is full empty. All right, so the next thing, what if you have data in a CSV format? So what you have to do with our algorithm? So if your data in the CSV format, don't confuse yourself, because it is going to be easy. There is no need to change the logic inside your algorithm. The only thing you have to change the format of your data set. All right. Okay, so if you see here, if you look at this, okay, so this is going to, how it is going to work. This is going to this is the same data set we have extracted. All right, print no m data. So this is the raw and data, whatever you can say. So how it is going to extract the information from here? So in the same way as we did for the text file, okay, so it is going to decide, it is going to extract the information in this way. You can see, so list, so it is deciding, it is going to extract all the information in the list. All right, and ILAC is used for targeting the row, complete row. Okay, and this is how, for example, length, so it is going to iterate for 99 times. Okay, so row is indexing, index is 1 0 1 2 3 4 5. So m data is using to extract the row 1, row 2, row 3, row 4. Okay, you can see here, let's see, print m data dot ilog row. There is no need to be used column here, I think. Yes, rows, it is row, no, it is going to be index 0. So because we are not going to extract the data on the column wise, so there is no need to be having a column names. All right, so this is how data is going to be extracted. And if you want to target the row 1, yani 0 1 2, if you see here, then ilog and 0, you see here 0 1 2 3. Okay, so when it is listed, then there is no need to be. Okay, you see here, so this is separated. Alright, this is how all the rows are extracted here, and this data is sent into the K cluster as we did here and calculated the best match. And this is how we extract the data from here and best sent into the K-mean cluster, as I said this before. And let's see how we have best matches. Okay, so this is the best matches nodes. So this is the best matches list, or you can say centroids, without changing the logic inside the algorithm. So the next thing that remember for us to predict the test value, or you can say and to measure the accuracy, so you can do this task by own. So thank you so much for now. Let's see how can we keep it continue. So next we will discuss something very better. Thank you.